In our next example for simplifying complex fractions, we have two fractions divided by two other fractions. So we do not have a single fraction divided by a single fraction here. For this technique, what we need to do is look at each individual denominator. So you can see that there's four different denominators. And from those four denominators, we're going to come up with the lowest common denominator. We have the quantity of x minus 3, so automatically that is a unique factor because it's the very first factor we're looking at. So part of our LCD will include the quantity of x minus 3. The next denominator has the quantity of x plus 5. That is different from our other denominator. So again, we have another unique factor. So the quantity of x plus 5 will be included in our lowest common denominator. Our third denominator is the quantity of x plus 5. Well, that's the one that I just wrote, so it is not unique. It's not raised to any different power, so I don't need to include it again. Our final denominator is the quantity x minus 3, which we already have included in our lowest common denominator. So the only unique factors are going to involve the quantity of x minus 3 and the quantity of x plus 5. So now what we're going to do with those factors is multiply every term in our complex fraction to eliminate fractions. So I'm starting with the first fraction, 1 over x minus 3, and I'm going to multiply that fraction by our factors in the lowest common denominator. Then I have a subtraction sign. Anytime I have subtraction, I'm thinking of including a bracket so I know to distribute that negative to any of the terms inside the bracket. So I start with my fraction, 3 over x plus 5. And I'm multiplying by the lowest common denominator. Close the bracket. Those terms are being divided by these other fractions. So I start with 2 divided by the quantity x plus 5. And I'm multiplying by the lowest common denominator. We have addition, so I don't need to worry about any bracket here. Starting with 7 over the quantity of x minus 3. I'll multiply by our lowest common denominator. So you can see that every term in this complex fraction is being multiplied by the entire LCD. Now let's see what will reduce. I have a quantity of x minus 3 in the numerator reducing with quantity x minus 3 in the denominator. So do you notice how there's no fraction remaining in that first term? That was the purpose for multiplying each term by the lowest common denominator. Inside the bracket, I have a quantity of x plus 5 in the numerator reducing with quantity x plus 5 in the denominator. Again, no fraction remains in that bracket. In our denominator of the complex fraction, quantity x plus 5 reduces, and our last term, quantity x minus 3 reduces. So now what we need to do is go back and rewrite what terms we're left with. I have 1 multiplied by this quantity. So that leaves me 1 times x and 1 times 5. So that would be x plus 5. Inside of the bracket, I have 3 times x and 3 times negative 3. That leaves me 3x minus 9. But that is still inside the bracket. So I have to remember that the negative will distribute now to each term in that bracket. So 3x is now negative 3x. And negative multiplied by negative 9 becomes positive 9. So that is the crucial step right there. When you have subtraction, don't forget to distribute the negative to any terms remaining in the bracket. So now we're going to look at the denominator. 2 is distributed to x and negative 3. So that would make 2x minus 6. With addition, I don't need to worry about distributing a negative sign. So it is a positive 7 that is distributed to x and then to 5. So 7 times x is positive 7x. And 7 times 5 would be plus 35. So now all I have to do is look for any like terms to combine in the numerator. 1x minus 3x would be minus 2x, and 5 plus 9 would be plus 14. In our denominator, I have 2x plus 7x, so that would give me 9x, and constant terms minus 6 and positive 35 will give us positive 29. Now we might look for an opportunity to reduce. I can see that 2 and 14 are both even numbers. So if I think about factoring out, I have a lead term of a negative. So if I factor out negative 2, I'd end up with x minus 7. In our denominator, the coefficients of 9 and 29 don't have any common factor. So it looks like we're not able to factor to reduce. That means our final answer is right here. Negative 2x plus 14 divided by 9x plus 29.